Right. So in this session, we'll be learning about 8051 serial communication. What we will study in this session is understand the theoretical aspects of what is serial communication, followed by the important resistors that are associated with serial communication. And further, we will look into an example how the data is being transmitted serially in an 8051 programming, wherein we'll write an embedded C program for it. So, what is meant by serial communication? So, serial communication fundamentally means the data is being transmitted one byte at a time, or it is a block of data that is being transmitted from the transmitter to the receiver. So, depending upon whether a block of data is being transmitted or a single byte of data is transmitted, the serial data communication is of two types or methods. One is the synchronous method, the other one is asynchronous method. In synchronous method, the transfer of data happens at a block, while in asynchronous, it a single byte of data is being transmitted. It supports, there is a software or other you can write a program which supports both synchronous as well as asynchronous type of data transfer. And it's just not sufficient that you have the program being written, but you also need to have the hardware which supports that operation. And hence, there are two chips, UART as well as USART. UART stands for Universal Asynchronous Receiver and Transmitter, while USART stands for Universal Synchronous as well as Asynchronous Receiver and a Transmitter. So, in this session, we will be looking into Universal Asynchronous Receiver and Transmitter. So this is the mode of communication, serial communication, which is supported by 8051 microcontroller. Right. Now further, when we look into the communication or rather in particular the serial communication, either it is simplex or it is duplex. So as you can see in this pictorial representation, in simplex, we just have. Yeah. So here we have a transmitter and then we also have a receiver. So, right, there's a transmitter and a receiver. In a simplex, if you have two devices which are communicating, one device will simply transmit the data while the other device will only receive the data. Right? Like for example, if you take the radio stations, right, the station is transmitting while the receiver you have is the radio unit which is there at home. Similarly comes the television as well. The other mode of communication that you have is a duplex, which means that there is a possibility of transmitting and receiving on both the devices. So when it is duplex, it is either half duplex or it is full duplex. What is meant by half duplex? Which means that when one device is transmitting the data, the other device will simply receive the data. On the other hand, when the second device is transmitting, the first device only receives the data. And that is what we call it to be as a half duplex. The next one we have is a full duplex. That means your device has a dedicated two sets, that is one transmitter and one receiver. Similarly, the second device also has a dedicated receiver and a transmitter. So there's a dedicated line or a dedicated path that is being set between the transmitter of the first device to the receiver of the second. Similarly, transmitter of the second to the receiver of the first one. After understanding the simplex and the duplex type of communication, now let's go into what is a protocol. A protocol is nothing but a set of rules which are being agreed between the transmitter and receiver. Why this is required? So especially when we look into a serial communication, you should understand that the transmitter and the receiver should be clear about how would be the data transmitted and received, because it's a serial. When you say serial, you have got simply series of ones and zeros which are being transmitted from the sender to the receiver. So there is a protocol. What is a protocol consisting of? It consists of the data is packed. How is the data being packed? That means whether you have the information, you have some start bit, you have some stop bit, what is indicated in the data as a packet. The second one is how many bits constitute a character. Very important because you're going to transmit byte by byte or a character by character. So, how do you define the number of bits for that particular character? The next important is when the data begins and ends. Right. So, these are the three key important, what you could say, as the rules that have to be set between the sender and the receiver. Next, coming to an asynchronous serial data communication, which is widely used mainly for a character oriented transmission. Each character is placed between a start and a stop bit. That means, if at all assume that you have a character A to be transmitted. Now, how do you transmit that A? A will be represented by its ASCII equivalent. And what is the ASCII equivalent of A? If it is capital, it's 47. So that is being represented as an information. Now, since it is going to be a combination of ones and zeros only, you need to indicate to the receiver when has the start of that particular bit of A happening and when it ends. So before you transmit the information, there is a start bit and a stop bit. So that complete block rather, which consists of the start bit, stop bit, and information in between, we call it to be as a framing. But in case of the synchronous method, you have a block-oriented data transfer. So the start bit is always one bit, but the stop bit can be either one or two bits. So it depends upon the controller what protocols have been set. So the start bit is always a low, that means a zero signal, while the stop bit is always a high. So this is the representation. As I said, we have the character A, wherein 41 is the ASCII equivalent of A. Now 8-bit binary is the representation. So as you can see over here, there is a mark which will be high, which will indicate the signal of the data to be transmitted. And then you have a start bit. So the start bit is 0, which goes as first, followed by remaining all of these are nothing but the ASCII equivalent of A, and then you have a stop bit and there is a space, which is again a low. But what is our concern over here is these 8 bits of the data, which is nothing but the ASCII equivalent of any character that is being transmitted, along with the start and the stop bit, together forms the 10 bit of the information. Now, next important, what you could say, the parameter or the component associated with the serial communication is the data transfer rate. So, what is the rate at which the data is being transmitted? So, that is being defined as bits per second, which is also known as the baud rate. So, the number of bits that are being transmitted per second is defined as the data transfer rate, and the term that we use is the baud rate. As we can see in this table over here, the baud rate can either be 9600, 4800, 2400, 1200, or you could also have the baud rate to be 19200 and so on. And each of these baud rate will have a decimal or the hexadecimal equivalent to be loaded with. We'll come back to this equivalent when we discuss about the programming part of it. So just remember that this is a baud rate which is supported for a serial communication, and generally or normally we use 9600 as the baud rate for a nominal data transfer that is happening between the transmitter and a receiver, or sender and a receiver. Now, when we have to study the serial communication, or when the data has to be transmitted from 8051, right, to another 8051, the data that is, for example, as you took A, should be held in a register. So the specific register which is used for data communication is SBUF, that is serial buff register. So it is a 8-bit register which is used only for serial communication. So whatever the data that has to be transmitted should be available into the SBUF register. For a byte of data to be transferred through the TXD line, that is a transmission line, should be placed into the SBUF register. So before the data is to be transmitted, the character should be available into the SBUF register. The moment a byte is written into the SBUF, it is framed with the start and stop bit. So the controller internal will take care of framing the information. What is that framing? Is nothing but having a start bit and a stop bit in between which you have the information of the data. So SBUF holds the data that has to be also received by 8051. So this SBUF register is a common register which is used either transmitting the data from 8051 externally or receiving the data by 8051 from an external line. It's a common register. So what is done here is when the bits are being received serially, that is through your RXT, that is receive data line, then it has to be framed because we know that for transmission it is being framed with the start and the stop bit. So on receiving the data, the start bit is eliminated, information is copied, and again the stop bit also is eliminated. Effectively, what we get is nothing but a 8-bit data into the SBUF register. The next register, very important, is the SCON register, that is serial control register. Now this is again an 8-bit register which is used to program the start bit, stop bit and the data which are the part of the framing. Now as you can see, these are the 8 bits that are associated here. So let's not really focus more on all these bits. Let us quickly understand in brief which are really important. Okay, so SM0 and SM1, right, are nothing but the serial mode register. In what mode you want the serial, what you could say, UART to operate. So in the normal serial communication, we'll be setting the mode to be as 0, 1. What does that mean? It has got 8 bit of data, 1 start bit and 1 stop bit. So in our discussion over here, the key interest would be on setting this SM0 and SM1 to be as 0, 1, that is serial mode 1. Then the second one we have is the REN, that is receive enable. So this is a bit addressable register. When it is high, it allows the 8051 to receive the data on this if low receiver is disabled. So for the serial communication to take place through the UART, the controller has to be activated for receiving the data. How do you activate that reception of the data? By setting bit 1 in the REN register, right? The next two important bits that we have of the SMOD register is the TI bit and the RI bit. TI stands for transmit interrupt. So how does a controller understand that the 8-bit of data is being received? It's only through this transmit interrupt. So on receiving the data, on transmitting the data, then what happens is the TI flag will be raised. That means it will be made 1. So that it indicates it's ready to receive the other byte of the data. Similarly, the RI is receive interrupt. So when 8051 receives a data through the RXT bin, so it removes or eliminates the start and the stop bit. So the byte of the data is available in the SBUF register. Then 8051 raises this RI flag to indicate that the byte of the data is being received. And then the data, whatever is there in the SBUF, would be copied into the local register. So 8051 microcontroller reads these TI and RI register to understand whether 8-bit of the data is being transmitted or it is being received respectively. So this is very important, but for us, we'll only focus on the TI because the problem statement what we are going to learn here is transmitting the data serially. Right. Now, the most important part is how do you program 8051 to transmit the data serially? What are the steps that are involved? The first one is you're going to write a TMOD register. TMOD is timer mode register. Now, if you remember, we said that there is a baud rate or the rate at which the data is being transmitted. Now, who generates this rate of data transmission? It is generated by the timer. Okay, so 8051 has got two timers, that is timer 0 and timer 1. Timer 1 is dedicated for serial data transmission or serial data communication, and it has one of the resistor which is the timer mode resistor. So the value of this timer mode resistor should be 20. There won't be change in this value because the mode of data transmission is fixed. What is it? It is mode 2, right? And it is timer 1 which has to be used. Hence this value 20H whatever is to be written in the TMOD is fixed. Next is you need to load the baud rate. As we discussed previously, normal baud rate that is being used is 9600. And the equivalent value, I did say that you need to remember those values. What is it? -3 or FD. So that value of -3 or FD is loaded in the TH1 register. So when the value is loaded in the TH1 register, once the timer starts, then it keeps on incrementing to reach the value of FF and decrements. By then, the rate of data transmission would be happening at 9600, which is nothing but the set baud rate. Next is we're going to write the SCON register as we discussed currently. SCON, that is a serial control register. What we said is the serial control register is used to assign the value. What is that value? The mode of data transmission. How would be the data transmitted? Using mode 1. So we are writing a value of 0, 1. Right? And next, what should be made? Even your receive enable also should be made equal to 1. Though it is transmission, you can either write 40 or a 50H. Most important here is the mode, that is 0, 1 should be set in the SMOD, SM0 and SM register. So again, this value of 50H would be fixed in the SCON register. Next is we need to start the timer, because the timer is the one which is generating the required baud rate. Hence, TR1 is nothing but the start timer bit in the timer register. So it is being made as 1. Then the character to be transferred should be written in the SBUF register. So if you want to transmit A or you want to transmit B, then it has to be made available into the SBUF register. So the TI flag is being monitored. So once you start the timer, the bit by bit, the data will be transmitting. Now the controller needs to check for this TI flag to see whether it is being raised or not. Now, right, if it is not being raised, it means that still the 8 bits of the data have not been transmitted. It will be raised only when the stop bit occurs. Once it is done, you need to explicitly clear the TI flag. When it is assembly, we call it as clear TI, or in C programming, we'll be saying TI is equals to 0. Then you go back to step again 5, wherein the next byte of the data is to be written into the SBUF register, and you keep on monitoring the TI flag. Once it becomes 1, that means all the data, when that character is being transmitted, again you clear the TI flag and you repeat the whole process. So these are the important steps for us required to write the program also for transmitting the data serially using 8051 microcontroller. Right. So as we said, what is the program that we are going to write as per the problem statement is write an embedded system or 8051 embedded C program to display the string hello world, right, on using the UART. So what we are doing here, or what is the logic here, is we'll write a function which will send one character to the serial port. We'll write another function that uses the function in step 1. What is that function? The function which will send a character by character, right? And then in the main function, we will initialize all the resistors. What are those resistors? As we discussed over here. The tmod resistor set to value of 20, scon resistor set to value of 50, th resistor to be set to value of -3, or fd, which was nothing but the baud rate of 9600. Then we need to start the timer, right? These are all the initializations, and bus sbuff having the data or the character to be transmitted. All that would be done in the main function. Then we are going to check for the TI flag, whether TI flag is equals to 1. The moment TI flag is equals to 1, it's an indication that the character is being transmitted. Then we will clear off the TI flag and we repeat till all the characters are transmitted. That means we'll repeat the whole process till hello world is being transmitted. So next, let us look into the program over here. So include reg51.h. So we'll see what is a function to send a character to UART. We have written a function as sendChar, and we are sending a variable as char_c. So this function is going to read that character which has to be transmitted. And this character is to be written into the sbuff. As already discussed, whatever is the character, it should be done. C is not the character C, but the data that has to be transmitted. The next is while not of TI. That means we are going to monitor or check whether the TI is equals to 1 or 0. Not of TI means TI is 0. The moment TI becomes 1, it will exit that while loop. Then we will clear the TI flag, and that's the end of the function to send a character. Next, let us look into the function where you have to transmit a string. So here in send string, we are going to define a parameter, right, as an attribute, as an argument, that is char str square bracket. Unsigned char I, which will be set equal to 0, while str of I. That means till it is a non-zero. The moment it becomes 0, it exits. I mean, it's done with it. Then you are calling the above function nothing but void send char. So when you call this function, you are calling the function to transmit a character. So the control would be transferred to this function. Whatever is a character would be sent into the sbuff. Anyhow, in the main program, we will initialize the timer and everything. Then this function is going to check for the TI flag. If TI flag is 1, which means that that character is already being transmitted, and then TI will be cleared, and so on. Right? And you increment the value I. That's the end of the second function. Important is the main program. What are we doing in the main program? We want to send hello world to the UART. So we are defining a character, rather we are defining a variable as hello as a character, because every character of that hello world will store 8 bit of the data. So the data type is sufficient to have it as a character other than the int or long int and so on. Right. So we need to initialize UART for 9600 baud rate so that it is adjusted for the simulator. So this is the normal baud rate which will be transmitted. The next, as discussed already, tmod will be set to 20h. H is a hexadecimal. How do you write it for a C program? 0x20, which indicates this timer 1 and a mode 2. Next, what else we need to initialize? We need to initialize the TH1 register for the set baud rate of 9600. What is a hexa equivalent of that? Is FD. Look at that. The frequency is 12 megahertz. So if this frequency changes for the same baud rate, this value will be different. It also depends upon the frequency of operation of the microcontroller. Then next we are writing the SCON register with the value of 50, which is nothing but 8-bit data is to be transmitted, one stop bit and the receive enable. Then as we will start the timer. So since it's going to be continuous, then continuously the baud rate would be generated. Then we call the function that is send string hello, right? And then we will stop the program while one. So this is the complete program which goes into. So after understanding this program, quickly we'll have the demo of the execution of the program as well, right? So let's see here. It's a same program that's being written. Okay. So char hello. Let me just yeah. So include rec51.h, then void send character char c, then sbuff is equals to c while not of ti, then ti is equals to 0. This function is mainly to send a character to the UART, and the next function we have to send a string with a null termination. What are we doing over here is we have defined a string of the type char as in passing through an argument. Then we have a variable of the type char as I, which is initialized as 0. So this I is going to basically act as an indexing for it, and then we will call the function that is send char of this. Coming to the main program, what are we doing in the main program is, in the main program we have defined a variable as hello, right, and as a char which will hold that hello world. Let us change this as message msg so that there is no confusion with hello world and the hello. Okay, then tmod is set to value of 20, then th1 is fd, scon is set to value of 50, and then tr1 has started. Then what we will do here is we will call the function that is send string. So instead of hello, it's the name of the string that is msg would represent n1. Very sure you all know how it is to be done. How do you execute the program, save it, and then build it. We need to get 0 errors and 0 warnings, as we can see. Then we'll enter into the debug mode. We'll say OK. So into the debug mode, right? Into the debug mode, we'll go to view, and then we have serial windows that are available, UART1, UART2, UART3, and so on. I'll just unselect this. So in the when you open up the debug mode, it won't be available. So go to view, then click on serial window, which is UART1. Right? So what is expected is that hello world should be transmitted here into the simulator window, that is UART1. Either you can do a step-by-step execution, or it can be a one-time. We'll not go with a step-by-step execution because it would take internally a lot amount of time, and hence we will execute it once. So once you execute, as you can see, the hello world is being transmitted over here. So this is how the data gets transmitted serially. Now you can also change the message, right? So instead of hello world, let us write as welcome to DSETM, right? So save, again build, and since we have the null character as a termination, so we'll not worry about the size of the string. Yeah, so we get the message here as welcome to DSETM. Fine. Hope this is clear on how do you write an embedded C program to transmit the data serially, right? And it's just not writing the program, you also need to understand the serial communication that is happening with the 8051, right? So just to brief on the complete uh, details or what is required for a UART is understanding of the serial communication. Then we need to know the resistor, that is SMOD resistor, right? Then we need to know a little bit of the TMOD resistor, the timer, that is TH1, and to start the timer. The SBUF resistor is mainly used to hold the data whenever there is a transmission or the reception happening, fine. And then the logic of the program, right? So with this, we will end our session on serial communication. Thank you. All the very best.